following illustration, we will study about the direction of the magnetic force experienced by a current carrying conductor when it is placed in a uniform magnetic field. So these are certain sets of examples where we can find out that the direction of the magnetic field keeps on changing in different cases. Now over here we have seen that there is a conductor and a current I is flowing in this direction. In this case there is also a conductor, but the current direction of current is different. So we want to find out the direction of the magnetic force experienced by this conductor carrying a current I when it is placed in a uniform magnetic field B. We know from one equation related to magnetic force of a current carrying conductor is given by this expression, okay, ILB sine of theta, where this theta is the angle between the current element I and the magnetic field L. Also, in certain cases we can write this expression in this form, okay, we can write the expression in that form, which is the magnetic force. So we want to determine where is the direction of this magnetic force. So we can make use of two rules, okay, the Fleming's left hand rule, where this force, okay, where we outstretch the fingers of the left hand in mutually perpendicular directions, in which this thumb indicates the force, okay, magnetic force, magnetic field, and this will be the current. So this central finger will indicate the direction of the current, which I have been indicated by this level, that will indicate the direction of the current. This thumb will indicate the direction of the magnetic force, okay, the thumb will indicate the direction of the magnetic force, okay, and over here your index finger will indicate the direction of your magnetic field, okay, magnetic field. So these are the directions, okay, these are your directions. So in this case, suppose if the magnetic field, if I find out what is the magnetic force for this particular example, first you have to align your left hand in this direction. So this is the direction of the magnetic field, which is the correct alignment of B in this case, and this is the direction of the current, which is moving downwards, which is given by this expression. So if you want to find the direction of the magnetic force experienced by this conductor for this example number 2, that means you first outstretch your fingers in this direction. So this will be the direction of the force. So first the direction of the field, second the direction of your current, and this thumb will indicate the direction of the force. So your force in this case will be perpendicular and upwards. So in this case I'll make use by this dot representing the force acting on this current carrying conductor, in which the magnetic force will move upwards. So if I have a wire, suppose if this red colored pen experience the wire, it represents the wire, so this wire will move in the upward direction. So this will be the direction. Next, for this case also you can make use of your right hand thumb or right hand palm rule, which I will elaborate in the next section. So from here, if you find out the direction of the magnetic force experienced by this first example, okay, by this first example, how will you find out? So again you have to make use in this case, but in this case, since the current is moving from the downward direction, so this will be the direction of the current, which is wrong. So you have to reverse the direction in that way. So when you reverse the direction of the way in that way, so this will be the direction of the magnetic field, and this will be the direction of this will be the direction of your current flow, okay, this will be the direction of your current flow, and this will be your force. So the field is in this direction, this is the direction of the magnetic field pointing in the correct direction of B, and the magnetic force, this current is also pointing in this direction. So this is the direction of the magnetic field, this is the direction of the current. So your thumb will be pointing downwards. So the force experienced by this current carrying conductor, in which the direction of the current is in this direction, so that force will be perpendicular downwards, represented by the cross, okay. There are also certain relevant rules where you can find out the direction of your magnetic force by using another rule. So I will make use of my right hand palm rule, in which I will outstretch my fingers first in the direction of your current, and then I will curl my fingers in the direction of the magnetic field. So in this case, making use of my right hand palm rule, so I will point my fingers in the direction of the current flow. So in this case, the current is moving from the lower direction to the upper direction, so I will point my fingers in the direction of I. So I will point my finger in the direction of I. So from here also I need to rotate, but if I rotate downwards, that will be the direction of B, which is wrong. So the direction of B is from left to right, so I will have to orient, I have to adjust my right hand in the proper direction. So from here, this will be my proper direction of the movement of current. So outstretch my fingers, my right hand, this is my right hand, outstretch my fingers in the direction of I. So this is the direction of I. These are the fingers in which it is point along the direction of I. Then I will curl my fingers in the direction of B. So first you point in the direction of I, which is this, and then you curl your fingers in the direction of B. These are the direction of B. So your thumb is pointing downwards, which means that the magnetic force on this wire will be moving downwards. So say, like for instance, if this is your wire, and if this is the wire, and if the current is moving upwards, and if the magnetic field is from this direction to this direction, then this wire will move downwards. Okay, this wire will move downwards. Then another illustration for number 3 is that when you see this current moving in the upward direction, again I will make use of my right hand. Okay, when I make use of my right hand, that means this is the direction of your current flow. This is the direction of your current flow. Fingers in the direction of I. Then when you curl your fingers in the direction of B, when I curl my fingers in the direction of B, my thumb will be pointing upwards. So the magnetic force experienced by this wire when the current is moving upwards, but when the field is from right to left, that means the magnetic force will be moving upwards. So this wire will move upwards. Then in this case also field from right to left, but the current is moving in the downward direction. So from here I will make use of my right hand. So when I make use of my right hand, that means I will point in this direction. So when I point in this direction, that means this will be the direction of my current. And then when I curl my fingers this side, so when I curl my fingers this side, so my thumb will be pointing downwards. So this is the direction of current. Then when I curl my fingers this side in the correct direction of B, then your thumb is pointing downwards, which means that the magnetic force experienced by this wire carrying a current I will be perpendicular and downwards. Cross, perpendicular and downward. Then another example, when the magnetic field is perpendicular and downwards, represented by this cross. So which means that the north pole of the magnet is from the upper side and the south pole of the magnet is from the lower side. So the direction of the current is in this direction. So I will make use of my right hand palm rule to find out the direction where will be the direction of this magnetic force by this conductor. So again, I'll make use of my right hand since this is the direction of the current. So I will outstretch my fingers in the direction of what? Outstretch my fingers in the direction of I. So this is the direction of I. But the direction of B is in the downward direction. So I will outstretch first my fingers in the direction of I. Then I will turn my fingers in the direction of B, which is perpendicular and downward. So my thumb is pointing in this direction. So which means that the magnetic force will experienced by this conductor will be in this direction. So which means that if this is your magnetic if this is your wire, and if this current is moving is this direction and the magnetic field is from upwards to downwards, then this wire will move in this direction given by this vector. Okay, so another example from here, you have this wire and this current is moving in this direction. Okay, the current I is flowing in that direction across that wire. So I will make use again of my right hand thumb rule, or of my right hand palm rule, and then point my fingers. Okay, point your fingers in the direction of I. Okay, point your fingers in the direction of I. So when you point your fingers in the direction of I, then you have to curl your fingers in the direction of B. All these cross indicates your magnetic field. First you point your fingers in the direction of I, then you curl your fingers in the direction of B. So when you curl your fingers in the direction of B, so your thumb will point in this direction, which means that the wire will move in the downward direction. Next, some illustration is in which the magnetic force, the magnetic field is pointing in the upwards direction, represented by these dots. Okay, all these dots represents the magnetic field which is pointing in the upward direction. So again, make use of your right hand thumb rule, right hand palm rule. So from here, the direction of the current is in this direction, okay, from lower to the upper part. Then from here, I will make use of my right. You have to adjust your right hand in a proper direction, okay. So from here, I will align my fingers in this direction. So this will be the direction. This will be the direction in which the fingers are pointing along the direction of I. So now, since the magnetic field is represented by these dots, okay, so all the magnetic field will be pointing vertical and upwards. So I will curl my, first you point in the direction of I, then you curl your fingers in the direction of the magnetic field vector, okay, in the direction of I, in the direction of I, then curl your fingers in the direction of B, represented by the dots. So your thumb is pointing this side, which means that the this wire will move in this direction. So that will be the direction of your magnetic force. So first in the direction of I, next your fingers in the direction of B, then the outstretched thumb, this will be the direction of the force. Similarly for this part, okay, for this part, that means you have to align your fingers in this direction, okay. This will be the direction of the current flow, this will be the direction of the current flow, okay, with respect to I, and then the magnetic field is pointing upwards, so I will curl my fingers upwards, then your thumb is pointing in this direction, so which means that the force acting on this wire will be on this direction. Similarly for this part, okay, you point your fingers, okay, you point your fingers in this direction, but when you curl downwards, that means this is a wrong representation of B, okay. So from here you have to align your fingers in this direction. So when you point your fingers in the direction of I, you point your fingers in the direction of I, then you curl your fingers in the direction of B, then your thumb, this thumb is pointing in this direction. First in the direction of I, first in the direction of I, first in the direction of I, then curl your fingers, then your thumb is pointing in this direction. So which means that the magnetic force experienced by this wire will be on the upward direction, represented by this vector. Then next case, for this part, the magnetic field is moving in the upward direction. So again, make use of your right hand palm rule, okay. First you point on this direction, okay, you point on this direction, so that it will be very easier to curl your fingers in the direction of B, okay. First in the direction of I, this will be the proper direction of I, okay, this will be the proper, all my fingers are pointing in the direction of I. So and then I will turn my fingers in the direction of B. So when I turn my fingers in the direction of B in this direction, so my outstretched thumb will be upwards, okay, my outstretched thumb will be outwards. So from here, which means that the magnetic force experienced by this conductor will be perpendicular and upwards, which means that the wire will move upwards. In this case, the wire will move in this direction. Next, for the two later cases, from here, this, okay, you have to align your fingers in this direction. So this will be the direction of movement of I, okay, this will be this fingers are aligned along the direction of I. Then you have to curl in the direction of B. So when I curl in the direction of B, my thumb, your thumb is pointing downwards. Again, point your fingers in the direction of I, then rotate your fingers in the direction of B, then your thumb is pointing downwards, then which means that this force, the force experienced by this wire, will be perpendicular and downwards. Then next, this will be the direction of your magnetic field. Then the direction of I is in this direction, so you have to curl you have to first align your fingers in the direction of I. So I have aligned my fingers in the direction of I, and then I have to rotate my fingers in the direction of B. So when I rotate my fingers in the direction of B is in this direction, so my thumb will be pointing upwards, so which means that this force experienced by this wire will be perpendicular and upwards, represented by this dot. So you can study different examples to find out the relationship between magnetic force when due to the current carrying conductor given by this expression. Thank you.